Origin of gold. We know that the element gold is a precious, dense, yellow metal. We make jewelries from gold because of its amazing malleable and ductile properties. You may remember from your chemistry class that gold's atomic number is 79. Electronic industries widely use gold in circuit boards since it is not only a good conductor of electricity but also most resistant to corrosion. But have you ever thought about gold's origin? Though we get it from the gold mines on Earth, the truth is it got created somewhere far away in the universe. Let us explore how this precious heavy metal may have formed in the universe. Do you know what elements were present at the Big Bang? When the Big Bang occurred, 13.8 billion years ago, the universe consisted mostly of hydrogen, atomic number 1, with just one proton in the nucleus, and a small portion of helium, atomic number 2 with 2 protons in the nucleus. However, now we see more than 110 elements in the universe. Where did all the elements come from? How did they get created? The short answer is stars created some of the elements, and subsequent cataclysmic events forged rest of the elements. Medium-sized stars like our Sun create light elements. Scientists have come to know that the thermonuclear process, occurring in and around the core of every star, creates some of the elements. For instance, what powers the Sun now is the nuclear fusion process that is going on in the central core. Because of the high pressure and temperature in the core, 2 hydrogen nuclei fuse together to produce a helium nucleus, releasing enormous energy in this process. During the next stage of our Sun's life, when it runs out of hydrogen, it will start burning helium in the core, producing carbon and oxygen. Once all the helium is used up in the core, the Sun is going to die after becoming a red giant, leaving a white dwarf in the core. A white dwarf is a highly compressed dim star of carbon and oxygen. Our Sun will not be able to progressively continue the nucleosynthesis process beyond carbon and oxygen because its mass is not big enough to create the required pressure and temperature in the core to fuse carbon, or oxygen, nuclei to produce heavier elements. However, the story of massive stars is different. Massive stars create heavier elements. Massive stars, with masses 8 m is the mass of our Sun, or more, are able to take the nucleosynthesis process beyond carbon and oxygen. Such stars can continue synthesizing elements up to iron in the core. Even these huge stars cannot continue the nucleosynthesis process beyond iron because iron's nucleus is not only very stable but also requires tremendous energy to fuse 2 iron nuclei. So, iron is the dead end for all these massive stars. If that is the case, how do all the elements heavier than iron get forged in the universe? The answer is cataclysmic events create very heavy elements. If iron core is the dead end, even in massive stars, how do we explain the presence of much heavier atoms in the universe? How did all the heavier elements get forged? Scientists think that the answer may lie in the cataclysmic events such as a supernova and the merger of 2 neutron stars wherein an incredible amount of energy is available to synthesize heavier elements. Let us briefly review what supernovae and neutron stars are. Supernova is a violent explosion, and the death of a huge star at the end stage of its life cycle. As mentioned above, stars like our Sun will end up as a white dwarf after using up hydrogen in the core first and helium next. However, a much bigger star continues the nucleosynthesis progressively in the core until its core fully becomes a huge ball of iron. As fusion stops in the iron core, the weight of the outer layers takes over and crushes the iron core. Now the core turns into a neutron star accompanied by a violent and massive explosion. This cataclysmic explosion is named as a supernova. The shockwave, during the supernova explosion, completely rips off the outer layers of the star. It also increases the temperature and pressure of the outer layers so high that it causes explosive nucleosynthesis. Scientists believe that this explosive nucleosynthesis can create heavier elements through the R process, a short form for rapid neutronization process. The remnants of a supernova are a neutron star and a huge cloud of gas consisting of mostly hydrogen, and helium enriched with other heavy elements. And from this huge cloud, next generation of stars and planetary systems are born. Even supernova's tremendous energy is not sufficient to create elements like gold and heavier element. It takes neutron stars merger to create elements like gold. As described above, some massive stars become neutron stars at the end of their lives after a supernova explosion. What happens to the binary system of 2 such massive stars? That could become a binary system of neutron stars at the end of their life cycles. These neutron stars spin at extremely high rate and are known as pulsars. They lose energy over a period of millions of years, and they slowly come closer to each other, and finally merge. This merger is another kind of cataclysmic event. Scientists have recently witnessed the merger of a pair of such neutron stars. In this collision, they have seen evidences for the presence of much heavier elements. This collision too may result in our process, which creates much heavier elements including gold. So, gold is formed during the merger of neutron stars. Okay, we get it. How did gold end up in gold mines on Earth? That is another story. As you may know, our solar system formed about 4.6 billion years ago. That is, about 9.2 billion years after the Big Bang event. During those 9.2 billion years, many generations of stars, both massive and not massive ones, must have formed and died. Some of the massive stars and binary system of such massive stars left behind huge clouds of gases after supernova explosions and subsequent neutron stars mergers. Those clouds, enriched with heavy and much heavier elements, were the breeding grounds for the next generation of stars. Our solar system was one of the next generation of stars that formed from the relics of the earlier generation of huge stars. So, when our solar system formed from the interstellar gas clouds, containing heavy elements such as gold, our solar system inherited gold and other heavy elements from those clouds. Earth too inherited some portion of the heavy elements. Still one puzzle remains. Now we understand that our Earth inherited heavy metals from the interstellar gas clouds. But, when the Earth formed, gold being a heavy element should have sunk to Earth's core as the element iron did. If so, how are we able to get gold or iron from Earth's crust, which is only 30 kilometers deep? Scientists believe that the constant collisions by asteroids, during the formation period of the Earth, should have brought some portion of the heavier elements to the crust. The point is, supernova explosions create some heavy elements, and neutron star mergers forge much heavier elements including gold. Remember, the piece of gold jewelry you are wearing is a souvenir of cataclysmic events that happened billions of years ago. This is the story of the origin of gold, and other heavy elements. Thanks for watching.